Hello ladies and gentlemen, welcome to chapter 18. Today we are going to talk about why atoms bond. Now, first off, remember when we're talking about the periodic chart, you have to talk about the A's at the top over the different groups. Don't worry about the B's, we don't care about them right now, just the A's. Remember that is going to be telling us about valence electrons. Also remember, when we are talking about an atom, in the first level, which is closest to the nucleus, you are going to have it filled at 2 electrons. The second level is going to be filled with 8, and then we're going to talk about the third level being filled also with 8. Now, this directly leads to a thing we've talked about before, but I don't think we've named, and that is the octet rule, which simply states that an atom with 8 electrons in its outer orbit is stable. And basically that just means when the outer valence level is filled. So in the case of helium, it would only include 2 electrons, not a total of 8. Okay, chemical reactions, which is what we're going to be dealing with, bonding and things like that, are going to happen in order to try to fill that outer level so that they're stable and non-reactive, just like the noble gases. Okay. Starting with hydrogen, just as a review, remember you have the atomic number, which shows the number of protons. You can tell from the chart that you are simply going to have 1 proton. If you don't remember how to get electrons, that is, it is the same as the number of protons. In order to figure out the number of neutrons, you need to look at the atomic mass, which is the larger of the 2 numbers, and this tells you the number of protons and neutrons. In order to figure out neutrons, remember what you do is the atomic mass minus the atomic number, and you always round the atomic mass to the nearest whole number. And if you have 1 minus 1, you should get that the neutrons are 0 in hydrogen. And you should have the basic structure of hydrogen with proton in the center and a single orbit with a single electron. Now, if you remember, the number of A groups show the number of valence electrons. And you can see from the chart it is showing 1A, so that means that there is 1 valence electron. And if you look at the hydrogen, it is indeed that the valence electrons, the one in the outer level, there is only 1. Now, when we're talking about bonding, we need to talk about something called electronegativity. And this is basically how well an atom attracts and holds on to electrons when it's bonded to other atoms. Now, if you look at the image, what you can see is you have, when they have 2 atoms with equal electronegativity. Little black dots are the electrons, and you can see that basically what's happening is the electrons are spending an equal amount of time around each atom. The atoms are sharing the electrons, and they're sharing them equally. Now, that only happens if the 2 atoms are the same type of element, like H2 or O2, N2. They have to be the same thing for there to be exactly the same electronegativity, because different elements have different electronegativity. So if we look at the next scenario, where you have one element that has a stronger electronegativity and one that is weaker, what you will see is that although they are still sharing the electrons, you have it where the electrons are spending more time around one of the atoms, in this case the A. And because electrons are negative, they are creating that part of the molecule with A to act slightly negative. Okay? And by default, the B is acting slightly positive because its electrons are spending more time around A than around B. Okay? So this would be, again, they're sharing electrons, but it's not an equal sharing because of the difference in electronegativity. Now, the third scenario is where you have one atom, in this case F, that has a strong electronegativity, and the Na, the sodium, has a weak electronegativity. And what you can see that happens is the sodium literally just gives up its electron. It only has one valence electron, and it gives it to the fluorine. And what ends up happening is the sodium becomes positive, and since it's lost something negative, and the fluorine, which is gaining something negative, becomes negative. Okay, so that is the third scenario of how things are going to work. Now, the main types of chemical bonds that we're going to be talking about in this chapter. First, you have covalent bonds, and this is where electrons are shared between the two atoms. Okay, you can see co together, valent, the valence level, that outer level. Okay, so the outer levels are together. Second type that we're going to talk about is ionic bonding. And this would be the last scenario that you saw. This is where electrons are literally given by one atom to another atom. Okay? So they come from one atom and go to another atom. The third type, which we're going to have to explain, is a little bit different than what we've seen there. This is metallic bonding, and this is when electrons are going to be shared with many atoms, not just two. And this is going to look a little different, as you'll see. Okay, next time we are going to go into covalent bonding, and you will be able to learn how to identify it as well as be able to demonstrate it. Okay, until next time.